I'm Eno Teresca. Thank you for this. I'm a principal engineer in AWS. Today, I'll be talking about architecting for high availability on Amazon S3. Now, S3 has been running for over 15 years now and has scaled to hundreds of trillions of objects. We've had to scale the hardware infrastructure while continuously deploying software for things like new features and updates. And we've had to do all of that while maintaining the high availability that customers demand from S3. Now, we just heard that S3 is highly durable. Durability meant that data is stored safely and it's not corrupted. Today, I want to talk about how S3 is highly available as well. Availability typically means that you as a customer can access the data whenever you need it. In this talk, I'd like to share some of the techniques we use in S3 internally for maintaining high availability, because I think you might find them useful in building your own applications for high availability. Okay, so let's get started. So here's the agenda. I'll start with measuring availability and what it really means from a customer's point of view. So then I'll talk a little bit about the end-to-end robustness in Amazon S3, a little bit about the hardware infrastructure and techniques to ensure robustness and good availability of each of the components. Now, this is going to be only half of the story. The other half is really going to be around techniques that we use to operate S3 for high availability. These are going to include things like continuous deployment, cell-based architectures, and also a culture that encourages deep root cause analysis whenever something goes wrong. Finally, we're going to take some of these techniques and apply them and see how we can build an application for high availability. Let's start with measurements. Now, measuring availability in a large multi-tenant service like S3 is bound to be challenging, right? So a big risk here, a big challenge is really having important availability problems be masked by things like anticipated and regular occurrences, such as hardware failures, or some of the network links might be flapping, right? Or the natural changes demand throughout the day. So for example, you might have a spike at some point during the day in demand. But as we know, if you cannot measure something, it just becomes hard to fix it, okay? So metrics for availability are going to be super important. Now, before we go and dive into the metrics themselves, let's look a little bit at this 10,000 feet view of Amazon S3, right? So we have a whole bunch of things here, right? We have availability zones, we have regions, we have more than 20 regions, more than 60 availability zones. Each of these zones is made of potentially multiple data centers, right? And inside each of these data centers, you have servers with hard disks, with a whole bunch of networking gear, with CPUs, right? And each of these parts might fail somewhere, especially at the scale that we operate. Now, you can have permanent failures, but you can also have temporary failures, like a switch dropping packets whenever the load is high, or a cable breaking. Now, those are going to be some of the hardware challenges that we have in place. Now, on top of this, we also have to continuously deploy software on what is more than hundreds of microservices that make up Amazon S3. So how do we deploy this software, and how do we tolerate all of these failures? And more importantly, what are some of the metrics we're tracking for availability? Now, a customer doesn't see this, right? All the complexity. The customer sees a nice abstraction, a bucket, right, that hides all those complexities I showed in the previous slide. Developers treat S3 as a black box, as a highly available dependency. So the question really is, how do we go from the messy reality I showed in the previous slide, the messy reality of a distributed system with components potentially failing all the time, right, to this nice abstraction of a bucket that has high availability that you can depend on whenever you build your application? So what does availability mean to a customer then ultimately? Well, let's look at some things which are kind of obvious invariants in a sense, right? Availability tends to be something that's personal. A customer's observed availability matters. So if they're having a problem there, if they're not accessing their data, it doesn't matter if you tell them that, well, everybody else is getting their data, right? That doesn't help. So the first thing to keep in mind is that availability really has to be measured per customer. And one thing we want to make sure is that we don't bias against more active customers. So, for example, we'd like to reason the same way about the availability of a customer that sends 1,000 requests per second, as well as a customer that might just make 1 request per second. Both of them matter, right? Now, the second part is, what's the metric going to be? And the intuition here is that, availability is the system experience when it matters most, which is usually whenever, for example, customers send requests to Amazon S3. They want them to succeed. So naturally, a metric here is the request error rate. How often did they succeed? How often did they not succeed? Now, that's not going to be enough because if you measure the error rate, if you measure averages throughout the entire day, things might look good. But perhaps during a period of work when the customer really, really needed to get some work done, during like a 5-minute interval or a 10-minute interval, things were not working well. So it becomes clear that you also want to measure availability per customer during a fine-grained time interval, right? If it's too long, then you might miss explaining short outages that are important to the customer. So again, we're going to measure per customer availability. We're going to measure the request error rate at a fine-grained time interval. Now, it turns out we're going to have to measure internally a whole bunch of other things as well, right? So here I'm throwing in some disks to this picture. I'm throwing some failure detectors and the repair fleet as well. Disks are just one of the components that is in our data centers, right? So we have things like continuous monitoring, canaries that run continuous tests that proactively seek to identify if anything has failed, and a whole bunch of things that allow us to measure not just the average, but also the distribution of failure rates, and also repair rates. How fast are we able to repair? Whenever our fleet, for example, how we're going to talk a little bit later about replicating data. How fast can we re-replicate the data in case something goes wrong? Now, all of these things then go into, all these failure rates and the time to repair go into this, what's known as an availability model, and into this nines analysis that you can read about on our documentation. Now, over time, we build models and we catalog these failures, if you will, for the future as well. And we constantly work towards reducing the repair time as well. Okay. So again, in a summary, measure per customer availability using request error rate during a fine-grained time interval, as well as be proactive about measuring availability in your system. And the most important thing is, if there is anything wrong, then repair it as fast as possible. Now let's talk a little bit about how things fail, and let's look a little bit at end-to-end robustness in Amazon S3. You have heard this before. Everything fails all the time, right? This is a quote we like to say internally. You have heard it mentioned already today. Now, this doesn't mean our infrastructure is actually failing all the time, but rather that we should expect it to fail at all times, and then we need to ensure that we can effectively plan for mitigating any customer impact. We don't want to have any impact on availability, even though things might fail, right? So let's start with some of the hardware infrastructure and failures. Back to this picture I showed earlier on. Let's take a top-down approach. So we had availability zones. We had load balancers, rack switches. So let's start from the top. So the first thing is that let's talk about facility failover and recovery. Buildings can fail. These are super rare events, but they can happen. You can have things like power cuts, flooding. You can have earthquakes and other hazards. Now, intuitively, to survive a facility failure, typically you need more than one facility, right? So you can fail over. In this world, to have more than one facility, we typically leverage the concept of an availability zone. These are independent failure zones that we offer to customers as well. Today, we have over 60 availability zones spread over 20 regions. And an availability zone is really a collection of one or more data centers that are physically separate facilities in a metropolitan area. They have power redundancy and network redundancy and so on, right? So we have now these buildings with all the hardware redundancies. So the next step is, well, how do we place the data? How does S3 actually place the data across these buildings, right? You might have seen that all our storage classes in S3 guarantee the 4 nines of availability. There is one of them, the one availability zone option. But all the storage classes in S3 basically place their data on more than 3 availability zones. So if any of them fails, you still can maintain high availability because you can just route the customer requests onto the other ones. Let's zoom in now into one of these data centers, right? Sometimes hardware inside of these data centers also fails despite our best efforts. So the goal there is really to protect the data, we saw that in the previous talk, while tolerating this low but constant rate of component failures, and also to make it available, to make the data available so customers can access it. Now, over the years, we have learned that you can expect a whole bunch of different failures here inside the system. You can, arbitrary failures of servers, drives, hardware defects. You can also have correlated failures across multiple devices. What are some of the techniques we're going to use to maintain high availability, even in face of these failures? Well, I'd like to talk about 3 of them. The first one is really to have redundancy and think about redundancy in everything. So you want power redundancy, you want data redundancy through replication. So here, again, I'm showing the disks. And this just shows one component, and data is replicated in our data centers across these disks. So if any of them fails, we can quickly re-replicate the data, and the customers don't notice anything because there's multiple copies of it. So they can still access the data from where it's available. The second thing, you'd also want to continuously improve failure detection, right? You don't want to wait until really the last minute here. So typically this means more tests, more canaries to proactively find out those failures. Now, sometimes this might also mean tuning the time that you wait to, say, declare a disk has failed so that the software that does the routing of requests can switch over to the redundant data quicker, okay? Sometimes this could also mean predicting ahead of time when certain devices are about to fail. Now, the third part is super important. We also want to continuously improve the recovery times, right? In this case, with disks, if anything fails, we want to re-replicate the data as fast as we can. Now, for example, in this picture, I'm showing a repair fleet that is elastic in the sense that its size and therefore the speed of repair is automatically tuned to the amount of data that needs to be re-replicated. So these were the permanent failures. Now, there's another class of failures which are called transient failures. They're not permanent. Things are going wrong for a while, but then they get better again. So component queues on the network could be temporarily overloaded. They could shed some traffic. Perhaps the DNS resolving might fail temporarily, but then it becomes better again, right? Now, what are some of the mechanisms that S3 uses internally to cope with these transient failures? Well, there are a couple of them, right? So there are simple things like error codes. You'd like to propagate the error code. So for example, if you get a 500 server or throttling code, you want to propagate it throughout the storage stack so that all the layers understand what's going on. In this case, if it was throttling, right, they can try again. You also want to do things like exponential backups with jitter, and you also want to retry when it's appropriate to retry. For example, to do DNS re-resolving. Now, all of these things are tuned internally in Amazon S3. And what is some of the advice that we give to the customers? Because they do use, although these parameters are tuned, they still use the client library, right? So one of the main things to keep in mind is always keep the AWS SDK up to date, because through the SDK, you pick up all the good stuff, all the fixes that we do in S3, and you can keep them up to date with your application. When it comes to things like re-resolving DNS, typically you also have to follow best practices for that. So for example, the Java virtual machine sometimes by default caches the DNS name lookups. And it caches it forever, okay? Now, because AWS might change those DNS entries behind the scenes to maintain high availability, we recommend that you tune the time to live in the cache for the DNS entry to something like 60 seconds so that the JVM automatically picks up these new DNS entries and resolves them correctly. And that also helps with availability because you don't have to restart the JVM, you don't have to take the downtime, okay? So we talked about hardware failures, some of them permanent, some of them transient. What else do we need to do to maintain high availability? Well, the other part is really about operational best practices. One lesson we learned over the years is that there are other things that affect availability in addition to handling failures. One of them is the organizational structure around software deployments. Okay, so we deploy a lot of software in S3. There are hundreds of microservices that make up S3, and they're constantly updated. Okay, now it turns out that the way you do those updates can make a huge difference to availability. So let's look at a couple of examples here. Now, one thing that we do is that we tend to deploy software gradually, continuously, but gradually. And we use this notion of a cell-based architecture. So a cell typically is a self-contained unit of devices that does useful work together. After a cell is updated, customers whose requests hit those cells usually see the new software, right? Now, why do we deploy one cell at a time? Well, the idea is that that gives us some time to measure and mitigate any negative impact of a bad update, right? We talk about how availability is personal. This is really about guarding for the reverse in a sense, right? If a customer has an availability problem, just make sure that the bad software doesn't impact everybody else. So we deploy one cell and measure, right? And then we have this technique that if there is a problem, we first always roll back. We don't attempt to diagnose the problem live. And then once we fix the problem, then we proceed and deploy it again, right? So cell-based architecture is going to be super important to reduce the blast radius and super important to maintain high availability. The second thing is good tooling. So good tooling is super important. In S3, we give operators good troubleshooting and mitigation tools. And our development teams really prioritize the development of such tools above anything else. So these tools tend to be, we want them to be precise and also useful for the task at hand so that the operator doesn't need to improvise during an on-call event. Operators, we don't want them to, the tools and the operators, we don't want them to, for example, require unnecessarily input that they can already automatically infer, right? And we also want them to perform safety and sanity checks and also fail safely. So tools help. Mitigation recovery is also important. We also want to make the operator's engagement easier by automating many of the recovery mechanisms when something goes wrong. Developers spend a lot of time writing good mitigation scripts and instructions for how to solve an issue, should it arise in practice. Now, typically, we try to automate the recovery steps as much as we can. And also, we develop all the tools with this principle of least privilege so that they have the necessary and sufficient permissions to perform only the task at hand. So, for example, we tend to disallow broad SSH access to instances. And also, we want to limit access privileges to times when there is an on-call event. All of these things add up and help for maintaining high availability for our customers. And then finally, I just want to talk a little bit about the organizational culture and how we do these reviews whenever something does go wrong. Typically, we want to identify the root cause and prioritize the improvements. All these meetings tend to be really non-judgmental. We sit together, and a typical review agenda, I just want to share it in case you find it useful for your organization as well. We talk about what happened, what was the user or customer impact, and then why did it happen? So we have this notion of the 5 whys, where we kind of go deep in each of the layers, right? Now, it doesn't have to be 5. It can be, it can be 2, it can be 10. But the point is that you really want to go deep and understand what went wrong in each of the layers in the system that led to this end-to-end problem, right? And then what do we need to change? And the meeting ends with action items and owners and dates. So I just talked about how operational best practices, whenever we deploy software, help with maintaining high availability. Let's now look at how we can apply some of these lessons that Amazon S3 uses to your own applications. Okay? A couple of things here. So let's use this high availability thinking from S3 and apply it to your applications. Now, the first question is, what parts of my applications will need this extra robustness, right? Now, if you're already using Amazon S3, you don't need to worry about that. That's already highly available. We're going to have to look at the other components now. What can go wrong? And let's consider this through the eyes of a hypothetical customer through 3 case studies. So in the first case study, we have a customer that wants its own customers, right, to continue to be served with no downtime, even when 1 or more of their compute instances are down. So this first application might either be stateless, or all the state is stored in S3, so we're not worried about state in this particular case, right? How are we going to get robustness in face of compute instance failures, either transient or permanent? Well, let's use some of the mechanisms that we used in S3. So in particular, let's use multiple availability zones where you can spread your instances across them. And you do that to then get high availability, right? You can also use AWS autoscaling, which helps you define the number of instances you wish to have, and also performs basic health checks. If an instance is down, it will bring it up automatically for you again, right? And that will ensure that you maintain high availability for your compute instances. As I said, if you're already using Amazon S3, the state will already be highly available. You don't need to worry about that. Now, if you happen to have state elsewhere, one important thing to do is to focus on fast recovery for that state and do the best you can so that the system comes back up in the state that you want it to with the full redundancy. In the second case study, we have a customer that wants their applications to continue to operate in face of transient network failures. Now, what were some of these failures? We want robustness basically in face of network glitches. Sometimes some of the routers or switches might be overloaded. Sometimes you can have a DNS lookup failure. Now, what are some of the mechanisms we used in S3? Well, we had a whole bunch of timeouts and backups that we tuned internally, and the main way we expose them, and one of the main ways that we suggest in this case study as well, is to just simply ensure that the AWS SDK is kept up to date. Many of our fixes go there, and by keeping it up to date, you just pick them up. Okay. Now, if you have something like something specific in the sense of like a DNS fails to re-resolve, do double check the rest of your environment. So for example, Sans JVM tends to cache the DNS lookups forever by default, and you'll need to change that. To change it to something like 60 seconds where the DNS re-resolves itself and you don't need to restart the JVM and you can maintain high availability. Now, in the third case study, we have a customer that wants to deploy bug fixes and new features more frequently, right? They don't want to do it once a month or even once a week. They just, whenever they have something fixed, they want to deploy it right away. But they might worry that their deployments might result in their own customers' downtime, right? So again, the goal here is to deploy new software with minimal or no downtime. What are some of the mechanisms we used in S3 for this? Well, we talked about how you can reduce the blast radius through a cell-based architecture. So perhaps whenever you're designing your own software updates, you can think about splitting your resources in cells and updating them one at a time. We use this technique of deploying, measuring, and then rolling back if there is anything wrong, and not attempting any diagnosis whenever there is a problem out there. Rolling back is always the first thing that you want to do to maintain high availability. We also talked about the importance of tools and the importance of the principle of least privilege. And in this case, for example, you might also want to guard against any operator or tool errors. So for example, disallow SSH if that's not needed for the task that you're doing at hand. So in summary, in this talk, we talked about how Amazon S3 maintains high availability and how you can use some of those techniques for your own applications as well. We started by talking about the importance of measuring availability. Then we discussed end-to-end robustness in Amazon S3, and we discussed things around permanent and temporary failures and how we mitigate those issues. We talked about operational best practices, in particular around software deployments, and how good culture there really helps maintain the high availability for the customers. And then finally, we put all of these things together and talked about how you can build your own applications for high availability using some of these lessons learned. Thank you.
Hey, Enno, thank you so much for that talk. So again, oh, sorry, I'm hearing myself in the other tab. All right, now we've got that fixed. We heard a lot about you from availability. I know folks in chat have been quite lively. So I'm going to open up to them to ask, hey, do they have any questions? While we are waiting on that, I figured I'd give you a little bit of an open-ended question. There are so many different ways that the S3 team works to make availability extremely high priority on S3. I guess, are there any really common pitfalls that you see that customers face or have faced that S3 starts to solve for them? And I know this may be rehashing some of the stuff that you've seen in your talk, but what are the common challenges around availability for customers that are out in the world today?
Yeah, absolutely. I think the main we've definitely seen some of these challenges. One kind of common pattern there is potentially adding complexity that is not justified to the application, in the hope that that complexity could make the application more available. So sometimes we see customers, sometimes overcomplicate their availability story by potentially having multiple copies of the data, right? And then designing potentially what could be a complex mitigation and recovery effort on top of that. And one of the advices we give there is that they can consider Amazon S3 as highly available already and potentially simplify their architecture by removing all those extra components, right? So because if you really look carefully at how availability ends up working at scale, right, some of those extra components that you put in place might themselves, not have the right availability themselves, and might themselves become, if you will, the bottleneck in availability, right? So keeping it simple with S3 usually works better than coming up with a complex solution on top of S3 for the data that you keep there. So keeping it simple is and avoiding complexity is one of the main messages here.
Yeah, certainly. I know that was avoiding complexity and moving logic towards exactly the part of the infrastructure that needs to have it is a way to reduce sort of the blast radius there. So a great answer. We actually have one question from chat here from Robert Tables. Their question is, how long did it take to change from dynamic partitioning with object key names, etc.?
Was the question around how long it took as a software development kind of exercise? How long that feature became available? Or is it more like how long does it take, when
yeah, I'd imagine so. So I.
Oh, yeah. Is that
yeah?
Is
So
the case?
I think the context there is from if you were talking about dynamic partitioning prior in your talk, from a change over time, or if it's for the developer. I'm actually not entirely sure. Robert, if you want to clarify there.
Yeah, I can't see the chat, but I can answer the question. Typically, each of these features, a feature like that is super important to get right. So typically goes through the usual kind of software deployment and software kind of like design practices. And the main thing we do there, we saw a little bit of that in the previous talk, is that we have this in-depth durability reviews, right? And those are tough and challenging because we want to make sure that we have covered for all the corners, right? So a feature like that typically takes a couple of months to get right. Now I don't remember the exact number of months for that particular feature, but that's kind of like the right ballpark there. And again, the durability reviews are key for getting such a feature right.